Thank you, Ukarsh, for finding that link. So today is the architecture meeting. We're going to go over the blockchain pieces with XRPL, and we're going to start with the NFT token. So one of the things that we're going to kind of in our architecture is we're going to have in Ortelius, we have like an application version, which is made up of component versions. And those component versions are then made up of like the packages that were installed into the container, things along those lines. So that whole hierarchy, when we create a version, is going to be exported out of our database and added to the blockchain as a, I can't remember if it's called a block or a transaction that's in a block. Either way, we end up persisting that transaction when we create the new version into the ledger. And because of the way the ledgers work, they don't want you storing, a gigabyte of data in the ledger itself, because it'll just slow down the computation of the chain. So instead, what you do is you do a pointer over to the data. In our case, it'll be the JSON data that we will persist somewhere else. So the concept is an NFT is where we'll actually store the data in another storage mechanism. Right now, for like the proof of concept, we're going to install the NFT into IPFS, which is it's like, I think it stands for Interplanetary File System. Basically, it's a distributed file system. And when we do that, it becomes an immutable file in the file system. So as part of this process, we need to make sure that we maintain immutability. So the blockchain, so the NFT will create us an immutable hash of the snapshot that we took out of that application version. So that JSON payload would become immutable. That would be placed in the IPFS, which maintains the immutability. And that's where this, let me make my screen a little bigger. No, it's cooperating. So that's where this hash comes into play. So this hash is how we would reference that JSON payload. That payload then it lives in the IPFS, and at the blockchain level, what we do is we make an association to the token in the blockchain. So it's basically a pointer to the NFT that happens on the blockchain side. So Joseph has been working on the process of creating the NFT, and in our GitHub repo, if I can find it, you'll see where he did an example in Node as part of the process. So here in Node, he's taking just an example JSON file that just has some of our SBOM data in it, and he is storing it into the IPFS as part of that process. So we can see where he's connecting up to the IPFS. So the NFT that we're using is nft.storage. It gives us a free, basically, place to store data in the IPFS world. So we don't have to create anything. We just get to reuse that public storage as part of that process. So we can see where he's connecting up through the token, and he's actually loading in the metadata here into the IPFS, giving it a description and that ends up returning us a basically that hash that we need to utilize. And then on the reverse, you take that that hash, and that allows us to go ahead and pull out of the IPFS and retrieve our immutable data. So this is going to be part of it right now. I foresee that we'll use the IPFS as a easy storage mechanism for our proof of concept. Down the road, I think instead of storing it into IPFS, that we'll need to store the token into like the Arango DB in some sort of mutable fashion. And the reason being is we want to be able to query the JSON file that we store over there. The way the IPFS works and the NFTs is you just have these hash IDs that we get to deal with, and that's not, we can't really go and query the hash ID, and we don't want to loop through every single transaction in the blockchain and then go over to take the token off of the blockchain, go look up the data in, retrieve the data, the JSON out of IPFS, then do our query. It's just going to be too slow. So we're going to have to, down the road, change the search mechanism of our data that's going to be immutable. So as part of this, the creating the token over in the NFT storage was pretty simple. Right now, I think this is written in Node, and Utkarsh, you're saying that there's a better set of libraries around Node versus Python. Is that correct?
Yeah.
Okay. So I think mixing in Node will be fine. If it makes our coding easier, let's go ahead and use the Node.js for our implementation. If we need to change it down the road, we can. Hopefully the process isn't going to be overly complicated. I think when we get into replacing the backend IPFS with an Arango DB, that we may need to flip out the libraries at that point. But I think for us during the proof of concept that that using Node or Python or Mix works perfectly fine. So that's kind of where what's happening on the NFT side. Now, the next part is getting the NFT and the Python, the blockchain linked together is the next step. And I believe, Utkarsh, you've done some work on that front with like creating a wallet and all those types of things.
Yeah, it's just a sample code wherein I'm just instantiating a XRPL wallet with some test credentials and fetching the information. If
Cool.
we have to make a transaction, we have to just write few more codes.
Right. Yeah. And are you using testnet or devnet?
It's a devnet.
Devnet. Yeah. So Ripple XRPL has provided a couple blockchain server networks, distributed networks that we can work with. One's called testnet, the other one's called devnet, and then they had the production one. So the high level is to connect to the ledger. And from there, we actually go ahead and create a wallet. This will be one thing that we'll have to look at when we generate our wallet, because the hard part with the XRPL ledger is it's designed to be used for cryptocurrency, and we're going to be using it for just more of as a transaction ledger. So when we get into this wallet concept, we may be generating a wallet with unlimited like dollars or tokens, or or we may just generate it with zero. And I don't know if we can generate a wallet with zero and keep on doing the transactions, but we'll cross that bridge down the road. So you get you connect up to the ledger, generate your wallet, or pick the wallet that you already have out there, and then you start signing and sending transactions into the ledger, and then you query the ledger for your information that's out there. So this is where when we put it all together, we connect up to it, we get our wallet, we do our transactions, and then we go and look things up at that level. Now, when we look things up, it's all going to be these tokens, these hash tokens. So like I said, it's going to be harder for us to find information. So when we make our bridge between Ortelius and the ledger, when we get the ledger token back on that transaction, we'll record that back over on in the Ortelius database side. So we'll make the link between the two in the Ortelius database. So that way, when we know that we created version 15 of our shopping cart application, that version 15 is located here. This is the transaction that occurred in the ledger, so we can then go query more information about that. Down the road, I foresee that what we have going on in the Postgres database will be migrated over to the Graph database or Rango at that level. Now, I think some of the steps that we need to do is we have to build up like a transaction list. And have you gotten to that point, Utkarsh, where you're building a transaction? And
Yeah, so the sample is very similar to what you were showing here earlier. It just they have done something in between. I'm not able to understand what they are doing there. I think that is where they are making the transaction, right? At line number.
yeah, let's see here. So connect to the network, configure your information. Wait for validation. This may be the one that we need to kind of put together so kind of like where we're at right now is we have the wallet working, we have the NFT working, and we need to bring the two of them together, and that's right. So we need to do the mint transaction, which is going to allow us to take the NFT that's in the IPFS and mint it together with the blockchain. So this is kind of like pulling the tokens together. So this may be where our next step that we need to look at is minting the tokens and bringing the two together.
Oh, yes.
And it looks like this one is in Node.js as well. So if you want to flip everything from Python over to Node.js, that works. It may just be easier to get some better examples instead of trying to translate from Node over to Python and write stuff. So let's see what they got going on here. So we're going to connect up to the Devnet server. We're going to get our account with our wallet. And I don't remember what burn token is. Oh, okay. So that's like pre-creating the token. So what ends up happening is in the blockchain, because the blockchain is a distributed network, um, they want to ensure immutability. They You put your transaction out into the network, and what ends up happening is you have a certain number of servers in the network that are going to go through and validate the transaction, and it's called a consensus network. So a series of distributed servers are going to come to a consensus about the transaction and say they all agree that that's a valid transaction and nobody messed with it. So when that happens, you go through this kind of staging of you go and submit your transaction, and then you have to wait a period of time for the consensus to occur before the transaction can be added into the blockchain itself. So it's a multi-step process that's happening. So I believe this burn token is creating the initial connection. We get our transaction, which will be our information about our NFT. We get that going out there, and then from there, see, this is where it gets hard, because we're talking about selling and creating, and we need to translate that into our world since we're not
Right.
doing selling and trading and stuff like that. So where is buy, create a buy? So this is where the sell and buy is if we're transferring the token, the NFT, to another person that's on the network. And I don't think at the beginning we're going to need to do that. I can foresee down the road that we have these transactions. So we have our application version on the blockchain, and then we can use the sell and buy and the offering to associate people that are consuming that NFT off of the blockchain. So let's say, give example, at a company, we've created our application version, and we're going to deploy it to the dev environment, and then we're going to deploy it to QA, and then we're going to deploy it to prod. Each one of those deployments is going to be another transaction that we can associate into the blockchain itself. So we have this ledger of where this thing ended up going. So we could have a dev buyer, a QA buyer, and a prod buyer, and they're all going to buy the same NFT. And that's where we'll start recording those transactions into the ledger as well, so we can see who's using it and where. And that scope would be not only at that local development, I mean, at that local company, but we can go globally with this as well. So for example, if we have WordPress, and WordPress, we have a version of WordPress that's been defined into Ortelius, and we have that stored in the blockchain and into the ledger. We can then, anybody that's going to consume that version of WordPress and then install it, we can have them be buyers and associate them to that. So we can go not only internal with a company, but higher level globally. And that's going to be the power of this. So let's say there's a PHP module inside of WordPress that has a security vulnerability. We can then see, because of we have a list of all the transactions of everybody that consumed that version of WordPress. We can then notify or associate and find those people to let them know that they need to do an update of that version of WordPress, a new version of WordPress because of PHP vulnerability. So that's the concept I'm trying to get to at that level. So initially, the buy and sell, we won't worry about that. We'll just get stuff onto the blockchain as NFTs. Does that make sense for everybody?
Yes.
So this is all around the transactions.
Steve, have you guys started building this already?
Yeah, we have an example that Joseph started working on. So in our repo here, we have the NFT piece where we're
cool.
placing our JSON snapshot of an application version into the IPFS storage. So that is done, and Utkarsh has the wallet side in place.
Okay.
So now the next step is to hook the things together.
Cool.
So let me see. And the nice thing about the XRPL, I believe they have a website that you can go and query like Devnet and testnet automatically, without having to write a bunch of code.
Oh, nice.
Okay, let's see what we got here. So yeah, so this one may be one for you to work with, Utkarsh. It looks like they have if I'm reading the code right here real quick. Send the token. Check the balances. Yeah. Yeah. So this will be where we would kind of associate together the information.
Yeah, exactly. That I was looking for.
Yeah. So let me drop this in the chat here. It looks like they have a couple coding examples. Oops.
Yeah, this repo was not coming in my Google search for some reason.
Yeah, it didn't come up in mine either. And here's the Python version of it. Not that much different than but the one thing I'm not seeing is, oh, that's just issuing a token. So somewhere, I think this token, where's send token defined? Anybody see send token? Trying to figure out where it's putting together the information. So if we go back over to here,
Actually, they call it as a transaction.
okay.
Yeah. I've shared one GitHub URL. Can you open
Okay.
that?
Let me.
So this guy has created
Cool.
isolated methods. Yeah.
What's the node again?
This one is not Ortelius. Basically,
Right.
he's sending the file in Pinata.
Yeah. But here, upload.
File in web. So here we can store in the S3 bucket or something.
Right. So instead of uploading it to the S3 bucket, we would put it over in the IPFS.
Yeah, he's also doing that IPFS, I think so.
Destination, right, metadata. Oh, here it is. Cool.
Yeah.
Yeah, this is a nice find. So yeah, once the file is placed in the IPFS, it will return the hash, and then that hash is what we associate back into the transaction layer. So if we go back over to here, we will have our hash here, and then we'll have a new token that will associate these two together, and then we push both of those into the blockchain. Let's see. Now this is where like the transaction types is going to be where it's going to be interesting. We'll have to play around and see what that other person did as part of that. So I think we're going to have to definitely use this token mint. I think this is new territory.
Yes.
Except for you sign and fill transaction. Oops, wrong one. Let's go to that one. Okay, so this is the SIDS is the IPFS hash number that we will get back.
Correct. That is a unique like ID card, unique identity.
Yeah.
Generated for a particular NFT.
Okay.
And we have update XRPF.
Sign transaction. That's more torrent stuff. I just can't seem to figure out where they do the association of the NFT. Okay, so we got our hashes. Then we connect up, get our wallet. Get our timestamp. It must be this one. This right metadata. If I'm following the logic correctly. Oh no, here's the SID. Okay. So at some point, just reading through this code really quick, it looks like that at this point, it's already been added up into testnet. So I think this is going to be a good example to try to give it a go. I don't think we'll need like the
Anything.
pinata, and we'll be able to strip a lot of this back. Get the wallet address. It must be in that. Nope. It's a mystery. So whoever finds it, let me know, because I'm curious how they make the association.
What are you looking for, Steve?
So what we have is, if we go back over to here, whoops.
Are you looking for it in the code?
Yeah. So
Can you not just do a Control F?
well, I'm not I don't know what I'm looking for.
Oh, okay, that doesn't. Okay, I see. Okay.
So what we have is we have our URI. So this is going to be that SID number. This is that SID that Utkarsh is talking about, the IPFS returns. So the way the whole process works is we take our JSON payload, we send that off to IPFS. IPFS creates that, persists that in the distributed network, and it returns a SID. That SID gives us this immutable reference to our JSON payload. So that's storing our JSON payload into persisting it on disk, basically. Now, the next thing is we need to record on the blockchain where that file lives in IPFS. And that's where, when we create our token, our NFT token on the blockchain side, we give it that SID as one of the parameters. And then we give it the token ID for where we're going to find that information in the blockchain. So if you think of the blockchain as a giant linked list, and as you go through and do these transactions, we're going to create a new transaction in the blockchain saying, I just created a new application version, and here's all the JSON data about that. The JSON data gets pushed over to the IPFS storage. We get the SID back. Now on the blockchain, we're going to record that transaction that we created a new application version, and here is the SID to go find the metadata, that JSON payload from that. So what they're trying to avoid is storing large amounts of data on the blockchain itself, because it just makes it slower. So you just store pointers to external storage for those the things on the blockchain. So that's why back at this level, they were storing data in IPFS and also an S3 bucket. So IPFS isn't required. You just need to persist somewhere, and then if you're worried about immutability, you have to make it a mutable reference to the file, and that's called they're called distributed hash tables at that level. So when you persist the file, you end up with a hash of it that, when we link things together, we can do the verification. So let's say we pull the token. We're looking for our application version that we just created. We can look at the blockchain, and we can then get our token, and then we can get our SHA here, which is the immutable hash of our JSON. And then we can go into the JSON file and calculate and see if we come up with the same thing. So we can do a verification to make sure that nobody messed with the data that was on disk. And that gives us this immutable ledger, even though things are broken apart on the storage side. So we have the blockchain storage, and then we have the data storage that happens on a separate type of system. But because we were able to create these hash tables and they end up being immutable, we can do verification and make sure nobody monkeyed with anything. Does that help?
Steve, in the file, there is one method like update XRP wallet data.
What line?
319.
319. Okay.
Yeah, they are making this transaction.
All right. There's the wallet.
There they are signing in at line 343.
Right.
And they are submitting it.
Okay. So somewhere in one of these, it's probably gonna be in the wallet data. So that's where I'm confused.
Yeah, that is a bit confusing because the file is getting stored in IPFS and the transaction, they have like a very different metadata stored.
Yeah, it has to be around the SID somewhere. Let's see. Okay, that's IPFS. That's all the IPFS. Return the root folder SID. Okay, that works good. We get our list of SIDs. Push them into an array. We return those. More stuff. Oh, okay. So here's our SID data. Okay. So it ends up being this in the build settings, the IPFS. So it looks like they're storing build settings into the blockchain. Let's see where they do that. Oh, okay. So it must be this resources. It's happening in here.
Okay, this is domain pointer.
So what it's doing is it's taking the build info, which has the list of the SIDs. And so here's our resources. So whatever this resources is, it looks like that is going into the domain field. So let's see where that guy is. 354. Okay. So yeah, so this is where they're doing it. They're building up the domain pointer. So we can see our SID there. Some of the other tokens where it's being stored. Oh, I get it. So if we go back over to here, let me see if I can find it. So when they talk about this token ID, you can see how that token ID is broken out into different pieces. And I think that's what they're doing in that domain field is creating one of these IDs with the different pieces kind of smashed together. So there's that transfer fee example, issuer. So I think that must be where they're putting it together in this domain data.
Yeah, so it's like updating the data before updating the wallet.
Right. Yeah. So you have to build. So this is kind of building up the transaction. And this is where I was saying they have a restriction on the number of bytes that you get to put into that domain information. So they're restricting it to 256 to keep the blockchain small. IPFS. So that must all get, let's see how they're smashing it together. Converting everything into hex.
Then returning the hex domain value. Yep.
Yeah, yeah. And then that domain value is then put into the wallet as a transaction. Okay. Starting to come together slowly.
Yeah.
So this is an excellent example that you found, Utkarsh. I would see if we can get this to kind of work.
I must say I'm very much the noob here. I'm gonna just be honest.
It's
Like
just
a t-shirt to me.
So like I'm also new here, so I've been reading out some articles around blockchains. That is only learning I have.
Yeah, and the XRPL documentation is actually pretty good.
Yeah.
So let's see, that was a node. Yeah, I think we may have to do everything in Node, I'm afraid, instead of Python. I think we're going to find more examples to work from.
Yeah, or we can do like once we can try to create one JavaScript application and then we can migrate that to Python.
Yeah, exactly.
Yeah, exactly.
We'll let you do the translation,
Yeah.
Sasha, between
the
Node.js and the.
I don't mind getting my hands dirty, yeah. But I will be phoning you, one of you. I'm really fascinated by this stuff, eh?
Yeah, it's going to be I think overall we have an idea of what we're doing, and let me see what this guy's repo is. I'll look at the README.
Actually, his code is working. So I ran day before yesterday or something.
Nice.
They have two images file and input. What the demo is about is making a transaction. So as a result, they create one output folder and pass the NFT there.
Yeah, and I'm sure we can ping this person. It's been forked 16 times, so. And it's relatively new. It's from last year, so it should be pretty. Oh, he has a demo. Did you watch the demo, Ukesh?
Yeah, YouTube one, right?
Yeah.
Yeah. Most of the stuffs were not working because of like installation, like Pinata and S3 bucket. But I got the idea, like what he's trying to say.
Yeah, and I think it looks like in the config file that you can tell it to what you want it to use. If you want to do IPFS or Pinata or whatever as the where to store the NFT.
Those are your file systems, right? Are those file systems?
Yeah.
Pinata and IPFS, right?
Yeah, there you can like we're talking, the IPFS is just at this point for us is an easy way to just store our JSON in an immutable format. The IPFS interface and their APIs allow us to do that really easy. It's just a couple calls to make that happen, and that gets us an immutable file that we can then work with on the blockchain side. Down the road, I think instead of using IPFS, we'll be using the graph database or something else, because we want to be able to query it. So the weird, and it's weird that nobody's come up with this yet, that you need to be able to query the NFT. So you want to be able to query the JSON data, and at the same time, you want it to be immutable. So it's one of those that we need to figure out a way to do that. And inside of IPFS, the way they maintain that is a distributed hash table. So each server that's in the IPFS world has a hash of the file. And if somebody goes into one server and messes with the file on disk, that the other servers will know about it and can cross-reference and say somebody corrupted us, or a lot of times they'll just have it be auto-corrected to put it back to the way it's supposed to be on disk from one of the other servers. So there's this whole concept of distributed hash tables and these servers communicating with each other to make sure that things haven't been messed with. When we look at what we're doing with Ortelius and bringing that into the Arango database so we can query those things, we may need some different implementations. Now, Brian Dawson told me that he has one of the folks from Ripple, they or the XRPL developers have Mongo instead of IPFS for storing the NFTs. And that's going to be very similar to what we're talking about. Mongo is just going to be another,
Document database.
the
Yeah.
document database, exactly.
Document, yeah. I've set up clusters for those before. Okay. Why did they choose that over IPF? Well, the other file systems. Why did they choose Mongo over IPFS? Is it just because it's, I don't know, more, it's so new, it's more known, or?
Well, IPFS is
and how do you run IPFS? Is it run like a Mongo, like a similar idea?
No, it's a distributed network, so it runs on top of libp2p.
Like peer-to-peer.
Yep.
So like
another concept.
Network.
Yeah, so it's like a different version of a BitTorrent. So each part of the network
type of protocol.
Yeah.
Yeah.
Oh, that's cool.
So each part of the IPFS system will store either parts of the file or all of the file, but it's truly distributed. So the possibility of something getting manipulated is harder to do. And there is a way to do it. You have to have take over, I think 20% of the servers you have to take over in order to corrupt the network as a whole. So if you have 1,000 servers, right? Yeah, if you have 1,000 IPFS servers out there running, you have to grab 200 of them to be able to start grabbing and corrupting the network.
Based on the same theory as a password, right? The longer or the more
Yep.
it is, you're going to need such massive computing power that it'll take lifetimes of people just to crack it in a way.
Yeah.
Okay, so it's based on that theory.
Yeah, it's based on. I have control because it's a consensus-based network as well. So there's consensus built in across all the nodes in the peer-to-peer network to make sure, and that's where the distributed hash tables come into play, where they all confirm that they have the same thing before they actually write it to disk.
Okay, and that's the ledger. That's the actual blockchain part, right?
That's actually on the IPFS side, and then on the blockchain it does it again.
So the blockchain, was it like a duplicate?
Well, the blockchain is going to be your transactions. So in our world, creating an application version would be a transaction. Creating a new component version would be a transaction. And then I don't know if you're on when we're talking about the buy sell process of the blockchain. So in the buy sell world, imagine we have WordPress. So we have a version of WordPress in the blockchain that Ortelius is managing. Now you have millions of people that are using WordPress across the whole world. We would know that we would have a buy sell transaction that would say that SiteGround just deployed into this server, this production server, this version of WordPress. That transaction, that buy sell transaction, would end up in the blockchain. And if we have everybody doing that, if we have some other rack space doing a WordPress install, the same version, what ends up happening is we have these transactions that are all pointing back to the same NFT that we created. Now we can see across the whole world everybody that's using that version of WordPress and where it's been deployed into what environments. Now, if there's a security fix that needs to be applied to some of the PHP code in WordPress, we know everybody that's consuming that version of WordPress and where it's been installed and what the vulnerability landscape looks like.
So in actual, the data would not be stored in a blockchain ledger, right?
The data itself is going to be stored in the NFT.
That's fascinating, man.
So, and the blockchain has a pointer to the NFT, and that's what we're trying to untangle with that code from that sample code that that person put together.
But if you're using a Mongo, would that be mostly for proprietary, just to yourself to use? You wouldn't use that because doesn't that make it more hackable? Doesn't that take the...
That's the part we need to figure out. So instead of so one of the possibilities is you mirror the data that is in IPFS and you mirror that into the document storage for querying capabilities.
I see.
Actually, there is this the Graph product which is used for querying on IPFS.
Oh, nice.
Yeah, I've dropped a link in the chat.
Is that the link you put there, Utkarsh?
Yeah.
Yeah, I went there now. APIs for a vibrant, decentralized future.
Yeah, let me grab that real quick.
Wow, this is incredible, eh?
Nice.
Mm.
Let me add it in to our issue real quick. So that's kind of where we're headed and what's going on. So kind of the next step will be to pull the NFT side and the blockchain transaction side together.
Okay. That was the part that I was struggling to put together. Was there's the NFT side and there's a blockchain side, and both of them are both have the data that you are is it both recording transactions, or the blockchain only records transactions? And what is the NFT? What is the
NFT is only for storage.
Only for storage.
Yeah.
Okay. Okay.
It's an immutable storage.
Okay. Ah, okay. Cool. That makes sense. Nice. Thanks.
So,
so clever. It's insane.
Yeah, and everything that happens is going to be because it's an immutable ledger. You can't go in and change something. So let's say we want to, in our component in our application version, we want to go ahead and swap out a component. We want to bump the component version in that application version. We've instead of allowing an update to happen at that level, you can never update an application version. You will only create new ones at that level. So you can take a previous version, create a new one, and in that creations process, you can do the update then. But it actually ends up being a new version. So everything you do is versioned and saved in the basically the transaction ledger.
Jeez. Okay.
And that will allow us to maintain history forever, basically.
That's amazing, eh?
So Utkarsh, are you gonna tackle the next step of pulling together?
Yeah.
Okay.
So the next step would be creating a sample application wherein I can just store an NFT and make a transaction.
Yep.
And somehow demo that.
Yeah, exactly. And we don't have to worry about like a S3 bucket or anything else, just IPFS. So at this point, our storage will be IPFS, and we'll be doing the XRPL ledger and hooking the two together. We won't worry about like an S3 bucket or Pinata or any other.
Yeah, I'll just remove all those unnecessary methods.
Yeah. And reach out to Joseph if you need help on that, because I know he did the NFT side in Node. So we have that code to work from as well.
So can I just ask maybe a dumb question again?
Yeah.
So how are we gonna do it? How are we gonna store our data around Ortelius?
Initially, for the proof of concept, we're going to store it in IPFS.
Okay.
And then I got to look at this link that Utkarsh just sent about the graph for searching IPFS.
Okay. Sounds like I'm gonna have to draw a diagram soon, or automate one.
And then, yeah.
So store our data in IPFS.
Yeah, and looks like this may be a GraphQL. I can't tell. I have to look at their. It's basically what we're thinking of doing as well. Basically mirroring the data into a searchable format.
Putting the data into a searchable format.
Yeah, so when you put things into IPFS, the only way you can find it is through the CID.
Ah,
If you don't have the CID, you can never find it again.
jeepers. It's there, but you can't find it.
Right.
So you can only find. And what is that? Is that the transactional data?
That's the data.
The actual. Okay.
Now on the transaction side, when we do a transaction, we record as part of the transaction payload that CID. So you can search through your wallet on the blockchain side, and you can look at all your transactions in your wallet. And for every transaction, you can go and get the CID, and then based on the CID, you can go to IPFS and get the data, the JSON data that's associated to it. But
Okay, well, sorry, can I just stop you there quickly? Is that data included? Is that like, if you're talking money, what the actual transaction took place, how much you bought and how much you sold, or whatever, something like that, how much you bought and sold, or and the value around that, and who did it? Is that kind of information in there?
that is part of the blockchain that we will be ignoring.
Ah, okay. But generally speaking, is that the separation?
Yeah. Yeah.
Okay.
So in the blockchain, you'll have there's a couple different transaction types. Well, one of the transactions, the main transaction that we're going to be focusing on first, is going to be the creating the NFT on the blockchain. And then another transaction would be like buying or selling the NFT. So those are the buying, selling are more like money based transactions where just saying that this is available, this NFT is available on the blockchain for purchase. That is what Utkarsh and Joseph are going to tackle next.
Okay.
And like I said, so you could theoretically find all of your NFTs from your wallet. So you can say, I created these NFTs. I haven't sold them yet, but I created them. And those transactions will be associated to your wallet in the blockchain. So you can loop through, because the blockchain is just a big giant linked list. You can think of it that way. You can then loop through all your transactions that are in your wallet and find the CID that will get you to where the actual data is stored in IPFS and retrieve that data then.
Thanks. Jeepers,
but the problem is if you want to query to say who's using log4j, which application versions are using log4j, you have to go into your wallet, loop through every single transaction, go pull the payload, the JSON, and then go query that JSON to see if that contains the log4j data that we're looking for. Now, if we have 1 million transactions, 1 million versions of our in our wallet, it's going to take a long time to loop through and go fetch everything.
Sounds like a lot of processing power you needed there.
Yeah, so that's where the offloading or mirroring the data or moving it outside of or somehow indexing IPFS will allow you to search, and you kind of go backwards. So you find the data that you're looking for, and then you can work your way backward to the CID, and then from the CID you can calculate to see if it's actually been corrupted or not. And if it hasn't been corrupted, you can then go back to see which transactions are in your blockchain to do the cross-referencing.
Jeez, fascinating, man. And that's probably why is that why Brian and them have a MongoDB to make finding that information faster?
Exactly.
Makes sense. Okay, it's like a cache.
Exactly.
A giant cache.
Yep. Now, when we're talking about like the WordPress example, if you have WordPress that's being used by, if it's being deployed to 100,000 servers and or 10 million servers, and because WordPress is pretty popular, I can imagine there's 10 million copies of WordPress out there.
Probably,
That
absolutely.
the scale that we're going to need to do the queries is going to have to be pretty quick, and that's where the graph databases come into play, because they manage relationships and do indexing to find things really quick. A 10 million row search in Rango DB is going to come back sub-second.
Oh,
Rango. What's it? Rango. R-A-N-G-O, like that.
Yep. DB.
Never heard of Rango DB. That's why I'm in Ortelius.
Yep.
So I can hear about things like Rango. Sounds like a restaurant where you can eat a lot of steak. Come to Rango's.
Yeah, so it's A-R-N. Yeah, it starts with an A.
My wife will be stoked. It's an avocado.
Let me drop the link in the chat.
This one, Rango, the multi-model database for graph and beyond.
Yep.
Sweet. It's an avocado for a icon. They must be amazing. Wow. So Steve, I don't know, there's probably time for this. But just quickly, a Rango, is it a NoSQL type of technology or what? Okay.
It's a NoSQL graph database, which is slightly different than like a MongoDB, which is a NoSQL database. So the way you do the queries in Rango is written slightly different than the queries you would do for Mongo.
Okay.
And now, don't confuse that. Now there's another one, which is GraphQL. So GraphQL is you would think it's the graph query language, but GraphQL is a RESTful API query language that GitHub created. And that's all about at the API level, of the RESTful API level, and it doesn't have anything to do with a graph database.
Okay.
Yes, that's confusing. Yes.
So you just have to be careful when you're looking at those things, what you're...
Yeah. Okay, cool. This is fascinating, man. This is so cool. Wow.
So Utkarsh, if you could reach out to Joseph and let him know what the plan is, and if he just the two of you kind of, and whoever else wants to work on this, kind of pair up. And if you could, when you got anything close, even if it's not a non-working sample, add it to that blockchain repo. Because that's one of the things for that grant we're working on. They want to check out our repo and the coding that we got going on.
Yeah, sure. So is that the same repo that Joseph was working on?
Yeah, same repo that Joseph is working. Just put a different directory in there. We can clean things up down the road, but just so we look like we have stuff moving forward around that grant, that would be a big help.
Yeah, don't worry, Steve. I'll check on them to make sure they're working hard, eh?
Okay, cool. I got to run, guys. I got another meeting to get ready for.
Cool, Steve. Thanks, Utkarsh.
Thanks.
All right, thanks for all the hard work, everybody.
Jeez.
Thanks, everyone. Bye-bye.
Cheers, guys.
Bye.